an answer when they did 237 divided by 4. How many people got this? 59.25. Who got that? Raise your hand if you got that. That's about half of you. Okay, how many people got this? 59 and 1/4. Who got that? One person got that? Okay, how many people got this? 59 with a remainder of 1. Who got that? Okay, so the rest of us. So check this out. So we have all these things going on here, right? Let's talk about why each one is individually unique and the importance for each one, especially this one down here. Why does this one play a role? I like that one. Okay, some of the process. Who had the process correct? What did you guys do? What did you do first? Yeah, so 4 goes into 23, then what did you do? 5 times, then 5 times 4 is 20, good. Subtracted. Bring down the 7. 9 times. 36. Subtract. Bring down the 1. Now what do you do, though? Put some zeros over here, right? Bring a 0 down. So that means the decimal goes there. Then what do you get? 2, 8, 2, 5, and then 5 times 4 is 20. So we're done, right? So that's where the 59.25 comes from. Okay, where does the 59 1/4 come from? Okay, yeah, you realize that 0.25 is 1/4. Yeah, that's true. But how does the 1 fit into this too? Yeah, what do you think? You put the remainder, right? So if we had stopped right here, right, we would have this remainder of 1, and we would put it over this 4 out in front, right? That's where we get the 1/4 from. Now it gets into my next part of my game here. Okay, what do you call? What color haven't I used yet here? Let's do black. Here we go. What do you call this thing underneath here?
Dividend.
Very good. This is the dividend. Okay. What do you call this number out here?
Divisor.
Very good. The divisor. Okay. Oh. Terrible writing. Okay, what do you call this thing up here? Just this part right here. The answer, the answer to a division problem is called a quotient, right? What do you call this thing down here? The remainder. Okay, good. So these 4 pieces of information here, these are all related somehow. How are these 4 things related to each other? Do you guys remember how I did it? Yes, it is division. That's true. But how are they related to each other? There's a relationship here. That's why I like this one. Okay, I think you know this, but I think you've never actually seen it written down. So let's write down the dividend. The dividend is equal to the divisor times the quotient plus the remainder. Is that true? Really? That's crazy. So let's check this really quickly. The dividend was 237. Is that equal to the divisor, which is 4, times the quotient of 59 plus 1? Is that true? It certainly is true, right? Yeah. That's because this is just 236 plus 1 gives you back the 237. So that's 237. So this piece of information here, this is actually kind of important. And it turns out that division of integers works exactly just like the division of polynomials. Or I should say the division of polynomials works exactly like the division of integers. So we're going to use this same process to figure out how to long. All right, so we're going to now apply what we did, right, to polynomials here. So the first thing we have to remember is what is the degree of my dividend here? What's the degree? Oh shoot, that's not how there. What's the degree of this thing? A degree of 2. Good. What's the degree of this thing? 1. Very good. How do you know that? Yes, the highest exponent, right? So in my dividend, I have an x squared term, and then I have an x to the first, and then I have an x to the 0. That's important that we have our exponents lined up in greatest to least format here. This is called standard form. So the degree of my dividend is the degree of 2, and the degree of my divisor is the degree of 1. And that's important because If it was the other way around, we'd have some troubles, right? We want our dividend to have a higher degree than our divisor. And we also want to make sure that each exponent is accounted for. So I have an x squared, I have an x to the first, and I have an x to the 0. Otherwise, I'm going to have to put a placeholder in. And we'll see why in just a second. All right, so how do I do this? How do I proceed? How does x plus 3 go into, or how do I divide this? Any thoughts? Yeah, Johnny, what do you think?
You isolate the x squared plus 10x, and then you multiply x plus 3 by x to get x squared plus 3x.
I think what you're saying is totally right. The question is, how many times does x go into x squared? Yeah, it goes exactly x times, right? Because x times x gives me x squared. So far, so good? Okay. And then we also do exactly, Sarah, what's x times 3? A positive 3x, okay? So I want you to notice a few things. One, definitely keeping my x squared column lined up. Definitely keeping my x to the first column lined up. And definitely keeping my constant column lined up. That's very important to stay organized in these types of problems. That's a procedural issue. So the next thing I want you to do is whenever we are subtracting, I want you to put parentheses around the entire piece and put a minus sign out in front. The reason is because every single year students forget to distribute that minus sign.
But where is the minus sign even coming from?
Well, check it out. We are following the same rules that we did up here. We are subtracting.
Oh, yes.
Yes. Same rules, right? So x squared minus x squared, what does that give us?
Wait, how did you get the 3x again?
I did x times 3 and got 3x. All right, you should get 0 here every single time. That's why I put a 0 with a line through it, because it's designed to give you a 0 down below. So what's 10x minus 3x? What does that give us? A positive 7x. Very good. Good. And then I bring down the 21. Okay, now 7. So what's 7 times x? Good. So we get a 7x down here. What's 7 times 3? Positive 21. Draw a line. We are subtracting. 7x minus 7x is 0. 21 minus 21 is, hey, remainder of 0. X plus 4. All right, so my dividend. What's the degree of the dividend now? 3. Good. What's the degree of my divisor? 1. That's good. Do I have every single term accounted for? Yes, I sure do, right? I have an x to the third. I have an x squared. I have an x to the first. And I have an x to the 0. I'm good to go. So, here we go. How many times does 3x go into 6x cubed? 2x squared. Very good. So, 2x squared times 3x is 6x cubed. 2x squared times a negative 2 is a negative 4x squared. So far, so good? Yeah. We're going to draw a line. We're going to subtract. We're going to get 0 here by design. We're going to get negative x squared minus a minus is plus. So negative x squared plus 4x squared, how much is that? 3x. There you go, plus 3x squared. Bring down my negative 5x. All right. How many times does 3x go into 3x squared?
Wait, how did that become 3x? Yeah, isn't it?
Because negative 1 plus 4 is 3. See, that's why you got to put parentheses around there. All right, so we ready to continue on? So 3x goes into 3x squared. How many times, everybody? Yeah, plus x, right? So x times a 3x is a 3x squared. X times negative 2, negative 2x, good. And then we're going to subtract. 3x squared minus 3x squared, that gives me nothing. Negative 5x plus 2x is negative 3x, good. And bring down the plus 4. Can 3x go into negative 3x? It sure can. How many times? Very good. Negative 1. You guys are getting this. Negative 1 times 3x, what does that give us? Negative 3x. Negative 1 times the negative 2? Positive 2. Draw a line. Draw a line. Subtract. We get nothing. And then 4 minus 2 is... yeah, so we have a remainder of 2. All right, here are your choices for your answers, okay? We've now identified everything. Here is our quotient. Here is our divisor. here is our dividend, and here is our remainder. So we have these four pieces here, correct? All right, so you can either represent the answer as 2x squared plus x minus 1 with a remainder of 2. That's one way to do it. Or you could say 2x squared plus x minus 1 plus 2 over 3x minus 2. Okay? The book, I don't know what the book's going to give you, but either one of those is okay, when you go to check, yeah, I have an x to the fourth, x to the third, but I don't have an x squared. So the way we would set this up is we would rewrite the whole entire problem as 3x squared minus 2x divided into 6x to the fourth plus 5x cubed plus 0x squared plus 3x minus 5. It's important that you have every single term accounted for by degree. So the fourth, the third, squared, first, and then 0. And you want to keep all of these lined up in your columns as you work downward. Okay? So when you work this out, you should get this for an answer. 2x squared plus 3x plus 2 with a remainder of 7x minus 5. So there are all the pieces. I've given you the dividend, the divisor, the quotient, and the remainder. You should be able to get that and then work backwards and check it to make sure that it is correct.